Hey guys, my name is Sandeep Patel. In this video, we are going to learn a new problem. We're going to solve a new problem on the array using the recursion technique. And the problem that we are given is we have to rotate an array by k elements on the right side, on the right. So how are we going to do this? If you haven't watched my previous video on the recursion, I would suggest you do that first, because in that video I explain in detail about how the recursion works and how we can solve recursion problems using the recursion technique, right? All right, so based on that video, we're going to take two-step approach to solve this problem, right? So step number one is we're going to break the problem into a subproblem first, and then we are going to solve the subproblem. So that's a two-step process that we are going to follow in order to solve this process. Okay, so let's say that you are given a function rotate array where you pass the array, and then this is k, the number of time you have to rotate the array, right? So for example, let's say that if you rotate this array 3 times, what happens, right? So first time when you rotate, the 3 comes in the first, so it becomes 3 1 2. The second time you rotate, the 3 comes in the middle, right? And the 2 comes in the front, right? So it becomes 2 3 1, right? And then another time you rotate, it becomes 1 2 3 again. So that means it's a full rotation, right? All right, so let's do this. So what we're gonna do first is that we're gonna break the problem into a subproblem, right? And how are we going to do this? So basically in this method, we're just gonna break this k variable, right? And how are we going to do this? It's like decrementing this one at a time. So let's say that first time we call this function, we initially had k, right? And then what we did is that we're going to reduce k by 1, and what we do is we take the last element and we put it on the front, right? Each time we decrement the k, right? So now k becomes 1, and now this 2 we put it here, and we remove this, right? 2 3 1, and then next time k becomes 0, and what we do here is that we put 1 in the front, so it becomes 1 2 3, the full rotation, right? And then when k becomes 0, we return, because now we already got the full rotation, right? All right, so let's cover that base case first, right? So step number 2, solve the base case, right? So if k becomes 0, then what we do is we return, right? So we return the same array, right? Otherwise, we call the same function, right? And we create a new array, right? Where we put the last element. So we took the last element of the array, right? Raise the last element array dot length -1, and then we take the slice, right? So we need to take the slice from 0 until the last element, before the last element, right? So what we do here is that we spread array dot slice. So we start with 0 and we add before end element, right? And then we can say k -1, right? So this will make sure that we cut the last element first, and then we spread the rest on the right side, right? Okay, and we also have to cover the case where array is 0, right? So in that case, we can also say if array.length triple equals 0, then we return the same array as well, right? Which is a blank array, because a blank array is a valid rotated array, right? All right, so let's see and the output. you can see here the blank array, it returns blank when we have 1 2 3 and we rotate by 1. This 3 goes in the front, so it becomes 3 1 2. And when we rotate 1 2 3 three times, it goes a full rotation, right? If I do it 2 times, then you will see what happens. The 2 comes in the front, 2 3 1, right? um, so I so now we're going to solve the space complexity, right? So this is step number 1, breaking the problem. So instead of breaking array, we just decrementing k, right? So that we are solving the problem by breaking the k instead of array, right? Okay, so now calculating the time complexity. So we're gonna check how many times this line of code runs when we call this function, right? So this is running 1 time, so O of 1. However, this rotate right will call k times, right? Because it depends on how many times the k is decremented, right? So instead of input, it depends on k. So I would say this is O of k time, right? So it's calling itself O of k time. So I would say time complexity O of k time, and the space complexity would also be of k times. Why? Because the function calls, when they're called recursively, it takes up the same amount of stack memory, right? So if this rotate right function called k times, that means there are k calls within a stack memory, right? So you can visualize this as a call stack, right? And this is in the stack memory. So you have these calls, right? So this first calls the second calls third, and third calls fourth, right? And then this start to return back, right? And then it will empty out the space, right, from the memory, from the call stack. So we can say that the rotate right is called k time. That's why we have the space memory O of k due to the call stack. Okay, I hope you like this video. Please do comment and like and subscribe. Thank you.